I didn't used to do this. I used to just do it on the board, and then I would wing it. I know it already, so I can write it on the board. But this makes me do every problem that I assign you to do. And I think that's really a valuable experience for me, because I can actually feel what it feels like to do all the problems. I won't go and say it's fun. I don't think it's fun, but... All right, this is a similar one, factoring the numerator. I'm going to go through this one a little quicker because we just did one like it. So you split that sine squared minus 18 sine t. You split it up into two pieces. I'm going through a little bit more here. So your plan is to backward FOIL this guy. So you put in what the first two and the last two have to be, and then you figure out the signs so that the outer and the inner add up to be minus 18 sine t. And you secretly had a clue that it might factor like that because the denominator is sine t minus 9, and just knowing how these problems work, you probably think this is going to cancel out. So there you have it. There's the original. There's the factored version. Out they go. Sine t minus 9. Thumbs up? This one's a little bit more scary. But you know what? A lot of math is bravery. Being able to look at something, I don't care how ugly it gets, it doesn't bother me. So be like that, be brave. Courage. Take the tangent t first and change it to sine t over cosine t. What that means is, when I have tangent squared, I have a tangent squared on top and bottom of that fraction. The tangent squared is really sine squared over cosine squared.
Is that a rule?
It's the same thing as squaring it. It comes because if tangent t, if I square it, and the inside part is sine t over cosine t, well, it's a rule that squaring a fraction means you square the numerator and square the denominator. So this becomes sine t squared over cosine t squared, which is the same thing as sine squared t over cosine squared t. Right, this square on the outside is the same thing as...
So sine over cosine.
Yes, always. So I'm going to do that. Looks worse. Sometimes I ask my students in Calc 1 and 2, why, if it looks worse and worse and worse every time you take a step, maybe you did something wrong. Here we didn't do anything wrong. It is worse. It looks worse. But what I have on top is I have a fraction and I have over another fraction. I'm going to actually combine these fractions. So right here, this 1, I'm going to get a common denominator. And 1s are easy, because to get a common denominator, I just have to put whatever the denominator is here, I have to just put it each over itself. So cosine squared over cosine squared is 1, and cosine squared over cosine squared is 1. And I did that so that these two have a common denominator. And then I'm going to combine them. That's the idea. And you're thinking she's making that thing look worse and worse. There it is. I just copied it again. So this is the same thing you saw at the end of that previous slide. Then you get, combining the numerators, you get cosine squared t minus sine squared t over cosine squared t. Just combining the fractions. Cosine squared t plus sine squared t over cosine squared t. And notice that this plus 2, it just goes along for the ride. It's just coming down every time. Good? So I copied again. This is what was at the bottom of the previous page. I have a fraction over fraction. It's ugly, but I still follow all the rules. The rules, the procedures that I have were all the same, right? I combine using common, I did the same work I would have done if I had 1/3 plus 1/2. I get a common denominator and put them together. It's just scary thing plus scary thing. So you put them together the same way. Now I've got a fraction over a fraction. You invert the denominator, not the numerator, just the denominator, and multiply. So this bottom here got flipped, and the top comes down. When you divide fractions, the second one turns around. It's starting to look a little bit better. Those go out. By the way, by the most famous identity, cosine squared plus sine squared is 1. I got a 1 there on the bottom. And how do you multiply fractions? The numerators get multiplied and the denominators get multiplied. So I have nothing left here, so it just, the numerator comes down, the denominator is only 1. And the 2 sine squared still comes down for the right. That was the last line of the previous slide. Now I get cosine squared minus sine squared plus 2 sine squared. I can combine these. 2 uglies minus 1 ugly leaves you with 1 ugly. So if I combine these two, I just get one of them.
Wait, could you go back? What did you do with the numerator and the denominator? Did you-
Here?
No, the
Here?
blue one.
This one?
Yeah, to get.
Right, this from here to here. I'm taking this ugly fraction and dividing it by this ugly fraction.
Oh no, I get that,
Right.
but you know what? You did the blue one, and then you got to like.
Right, this part just ended up being 1. 1 times, right, these cancel, so this is a 1 here too. 1 times 1 is 1, that gives me the new denominator. So if you had 1/2 times 3 halves, you take the 1 times 3, and that would be your new numerator, and 2 times 1, that would be your new denominator. So I'm just multiplying the denominators here, I just get a 1.
And how come?
And here, there's a 1 here. When these cancel, it's like you had cosine squared over cosine squared, it's just a 1 now. Right, so these are 1s now. When you slash them, they turn into 1s. And so you get cosine squared minus sine squared on top, that's all that's left.
But how come you didn't use the cosine squared plus sine instead of?
Because it's 1. Up there at the top, I'm using the most famous identity, cosine squared plus 1 squared.
So you're gonna give us the identities?
No, not this one. Most famous, you gotta know most famous. I'll show you how to cheat your way through the rest of them. But this one you gotta know. And if you get into Calc 1 and don't know it, you had PreCalc from Dr. Song. That's S-O-N-G. You know what? Dr. Song's taught a lot of students here. Everybody says they had Dr. Song. So that thing turned out to be kind of nice at the end, and it's going to get nicer. I'm going to combine this, the 2 uglies minus 1 ugly, gives you just 1 ugly. And what do we have here? 1. That's the most famous. See, up at the top, most famous.
So
It's always 1.
most of our fonts will be using the most famous?
You will, and from, you know what, the rule I have, I might get in trouble for this, maybe I shouldn't record this. The rule I have is, if I have it memorized, you have to have it memorized. Because if I have it memorized, there's a reason why I have it memorized. The double angle formulas, the sum formulas, I don't have them memorized. So my rule of thumb is that one. If I got it memorized, there must be some reason. And the other ones, I got a PhD after all, so I just looked them up and got away with it. So that means you can look them up and get away with it.